Right, so this is the Excel sheet. I just wanted to go through it quickly. We have the different beams here, and of course we put in the shear force and max bending moment from the shear force and bending moment diagrams for each beam. And then over here we put in the formulas that we have written down for tau xy, sigma x. So for example, the beam 2, where we had the axial loading, in this case we have the bending stress plus the direct stress. Right, so you could go through the equations if you want and link it back to what we have written on in the PDF. Just for sake of clarification. Also over here I included a pipe schedule chart from the internet, and we had said that we will look at using a 1-inch schedule 40 pipe. So the 1-inch pipe, the outside diameter is given here 1.3 inches and the wall thickness is 0.133 inches. So this is over here, and then we need to convert that to meters, which is what we do over here. Right, so you can see the formula for that there, multiply by 25.4 to bring it to millimeters, divide by 1000 to get it to meters, and we divide it by 2 afterwards, which is over here to get R2. Similarly for thickness, convert to millimeters, convert to meters, and then we divide, we subtract it from the outside radius so that we could get the R1. And we calculate our A, our I, J, Y. This is the yield strength. Use here 270 megapascals, which is more or less a conservative value for mild steel. Of course, for higher carbon steels, this value will actually be higher, it will actually be stronger, right? But 270 is always a good conservative estimate when you're working with steel. And beyond that, if you're using higher grade steels, but then you could go online on MacBook, for example, and get the strength of higher steels. Sometimes you would see steels at 350 megapascals. Those are stronger steels, but again, we just looking for now for we designing on paper, so we just need a estimated value, and 270 is a very good ballpark figure for a lot of mild carbon steels. Factor safety is 2. Again, is a conservative value until we do factor safety lecture. Then for now we will use it as 2. So the tau design, which is sigma yield on 2n, is calculated here. So the value converted that to megapascals, so it'll be easier to see and to read, and you can actually compare the tau max value from each beam to your tau design value. So you can see all is less than, so that means that the design is actually safe strength wise. Right, so you could even go further, and if you want, you could try and put in, for example, a 1/2-inch pipe. So it changes here to it changes these two values to match the 1/2-inch pipe and see how it compares. Now as we move on, and later on, coming on to the end of the semester, I'll talk about deflection. So yes, it might be safe strength wise, so it will not begin to bend or anything, but it could start to sag, it could deflect. Right, and that might be undesirable from a design perspective. Right, so for now, the strength aspect of it, we are good in the design.